So in this activity, we're going to find how to find the volume of several different types of solids. After this, you could probably find the volume of just about anything. And we want to start out with a sphere. So let's look at this example. Our definition tells us that a sphere is the set of all points a given distance from a fixed point. And in our picture down here, what that means is that every point on the sphere is a distance of 3 units away from the center. We also have our formula here for the volume of a sphere. And all we have to do to find the volume is substitute our radius into that formula. So instead of writing r cubed, I'm going to write 3 cubed since my radius is 3. 3 cubed is 27 because 3 times 3 times 3 is 27. So then our volume simplifies to 36 pi units cubed. So the sphere is straightforward. Just substitute your radius into the formula and find the volume. Now let's take a look at prisms and cylinders. The formula for the volume of both of these is the same. It's equal to the area of the base times the height. The bases of prisms are parallel to each other. I'm shading the bases of my pentagonal prism. It's pentagonal because the shape of the base is a pentagon, and I'm shading the bases of my cylinder as well. Cylinders have circular bases. So you can see that both cylinders and prisms have parallel bases. There's 2 of them. And the lateral faces of a prism are rectangular, while the lateral face of a cylinder is just one big rectangle if we were to unfold that. So we've been asked to label the base, the edges, and the vertices. So I colored my bases there. I am going to put a red dot on each of my vertices. So I can see that I have 10 vertices on this prism, and then I'm just going to highlight my edges. I have 5 edges connecting my 2 bases, and each base also has 5 edges that make up the sides of the base. So altogether, this has 15 edges. Now let's label our cylinder. I already highlighted the bases, and the little dotted line going up through the center of my cylinder is called the center axis. So you can have right prisms and oblique prisms, or right cylinders and oblique cylinders. To draw a right prism, draw 2 congruent shapes and set them right on top of each other, and then connect their corresponding vertices. Ta-da! It's a right prism. That's because the height of the prism is perpendicular to its bases. So in an oblique prism, the lateral edges are not perpendicular to the bases. So imagine that I have kind of a sideways slant to my base. The same is true for cylinders. For my right cylinder, I'm going to have 2 bases, one on top of the other, or it could be sideways, that would work too. The key thing is that the bases are perpendicular to the lateral face. That is not the case in an oblique cylinder. An oblique cylinder is kind of tipped diagonally. We actually use the same formula for the volume of both oblique and right prisms and cylinders. The key is that when you look at the height is always going to be a measure that is perpendicular to the bases. So our height is going to be perpendicular to the bases. Just be careful and be sure you're measuring the right one. This, for example, is not our height. As long as you identify the correct height, though, you're good to go and use the same formula. The volume equals the area of the base times the height. So let's do a couple of examples. Both of these examples are going to use the same formula for the volume, and I'm going to start out by finding the area of my base here with my triangular prism. So the area of a triangle is equal to 1/2 times the base of the triangle times the height of the triangle. Now remember, the height of the triangle is not the same thing as the height of the prism. We may use h for both of them, but the height of our prism is 10, while the height of our triangle is 4. So since the height of the triangle is 4, the area of the base is going to be 12. We already said that the height of the prism is 10. Remember, the height is always the distance between the 2 bases. So for our volume, we just multiply these together. 12 times 10 is 120, and whatever our units are, it would be cubed. So we're going to use the same process for the cylinder over here. First, we want to find the area of the base, so we'll use pi r squared since it's a circle. So that's going to be pi times 2 squared. That's just 4 pi, and I'm going to leave my answer in terms of pi. Why not? So the area of the base is 4 pi. The height of the cylinder, or the distance between the 2 bases, is 5. So let's multiply those 2 together for our volume. That gives us 20 pi units cubed. Our next step is to look at pyramids and cones. And for pyramids and cones, our formula is very similar. It's that the volume is equal to 1/3 times the base times the height. So a pyramid has a polygonal base and it has triangular lateral sides that meet at the apex of the pyramid. So in this case, we have a hexagonal pyramid because our base is a hexagon. All of the lateral faces are triangles, and at the very top, we call this the apex. And just like with prisms, you could have a right pyramid where the center axis of our pyramid is directly perpendicular to the base, or you could have an oblique pyramid. It's kind of fun to draw a pyramid. You just start with your polygonal base and then you draw your apex. For my oblique pyramid, it's going to be off to the side, and then you connect the dots. So a cone has a circular base and it also has an apex at the top. And for a right cone, the center axis is going to be perpendicular to the base. But for an oblique cone, the apex would be kind of off to the side. And just like with cylinders and prisms, we can use the same formula whether our shape is oblique or right. The key thing is just to identify the correct height. So this would be the height on my oblique cone. This would be the height on my oblique pyramid. And the height on my right cone and my right pyramid goes straight from the apex to the center of the base. The height is always going to be perpendicular to the base. You may also call it an altitude. So here's some examples. Remember, the volume is equal to 1/3 times the area of the base for both of these shapes, both the cone and the pyramid. My tick marks indicate that this is a square pyramid, that all of the sides have the same length. So that means that the area of my base is just going to be 10 squared, which is 100. And the height of this pyramid is 7. So then the volume is going to be 1/3 times 100 times 7. I'm just going to write that as 700 over 3 units cubed. Now let's do our cone. Our base is a circle, so it's going to be equal to pi r squared for the area. Our radius is 5, so that's pi times 5 squared. 5 times 5 is 25, so the area of the base is 25 pi. And the height of the cone is 8. So we're going to multiply 25 pi times 8, and we're going to multiply that by 1/3. 8 times 25 is 200, so I'm just going to write 200 pi over 3 units cubed. So now we know how to find the volume of all the basic shapes. Let's spend a minute talking about composite figures. Composite figures are just like think about playing with building blocks. Here we have a prism and a cylinder, and the cylinder is stacked on top of the prism. If I wanted to find the volume of this, I would just find the volume of the cylinder and then add that to the volume of the prism. That would be the volume of that whole figure. You can also use subtraction for composite figures. So for example, over here we have a drainage pipe, and we want to find how much plastic we need or metal we need in order to build a pipe like this. We want to know the volume of the material used to make the pipe. I guess that would be concrete. Apparently it's a concrete pipe. Well, in this case, I'm going to find the volume of the big cylinder, and I'm going to subtract the volume of the little cylinder that's inside it. The little cylinder represents the hole, and the big cylinder represents the pipe. So the volume of the big cylinder minus the volume of the little cylinder would give me the volume of the material that I need in order to make that pipe. And you already know how to find the volumes of cylinders and prisms and cones and pyramids, so you can find the volume of any composite figure that you're likely to run into. So we talked about 3 families of formulas. We had the volume of a sphere, we had prisms and cylinders, and we had pyramids and cones.